Okay, so in our previous class, what did we treat in our previous class? Okay, so we treated promises, async, await, and some ES6 features. So in today's class, we will continue with ES6, but we round up ES6 today. So for today, we'll be looking at the map, the WeakMap, set, BigInt, optional chaining, knowledge coalescing operator. So, but before we proceed, if you have any question or anything you want to say, please, you have to raise up your hand and just to call my attention, just raise up your hand before saying anything. Thank you. Okay, so let's proceed with map, the first item on our list. On the map, we have a map and WeakMap, but first of all, we look at the map. And we try to look at its uses, how to create map, adding and accessing elements, checking for existence, removing elements, iterating over keys, values, and entries, clearing the map, and checking the size and emptiness of a map. And then we'll also look at the weak map and the difference between the weak map and the map. Okay, so in order not to waste time, what is a map? Because I guess you've been hearing about a map and weak map in JavaScript, and probably some of you might have used it in one or two projects or one or two ways, I don't know. But today we'll take a look at the map and what it entails. Okay, so actually a map, in JavaScript, a map is a collection of key value pairs. It's a kind of similar to traditional JavaScript objects in terms of storing data and other features. But what makes it different from traditional JavaScript objects is maps are ordered. Like they kind of remember the order in which key value pairs were inserted. This is not the case in traditional objects where insertion order is not guaranteed. And in maps, key can be any data type. So what maps does, it allows you to use any data type like strings, numbers, objects, and even other maps as keys. And in traditional objects, it only uses strings or symbols as keys. And maps has also a size property. It has an inbuilt size property that reflects the number of key value pairs currently stored. So objects don't have a direct way to get the number of key value pairs. So in creating maps, map is actually an object. It's actually a class that you can call using the new keyword. So in creating maps, you can do something like, okay, so in creating maps, you can do something like const my map is equal to new map, like this. And you've created, this is actually an empty map. You've created an empty map. Okay, so pardon me. You've created an empty map and you can add and access elements in this map. So in adding and accessing elements, elements have keys and values that you can use a key to actually access the elements. So let me zoom in a little bit so we can see what's going on. Okay, I think this is enough. Okay, so this is how to create a map, a const keyword, or you can use let, but you don't want to actually change the variable be assigned to a map, so you can use the const keyword in order not to change it. So you can use the name of the map, then you can assign the map to a variable, new map, and this map is an empty map. Then you can add items to this map. You can actually see my map that now you want to add an item set. And then what is the key? You can actually see, you can actually use a string as a key. It's a name. And here you can see KodeCamp. Let's do something like, let's log the map on the console. My map. And we have an item here which maps, this key maps to this value. Name here is KodeCamp. And you can set another value. You can actually use, let's say here we have another value we want to set, map or set. We have, let's say the value is a number, and sorry, the key is a number, and the value we want to set is say key for second value, like this. In this scenario, if we log a map on the console, we have two items. The key here, the first one, the key is name and the value is KodeCamp. The second one, the key is 1 and the value is key for second value. Okay, see, so this is basically how we can create and then add elements to a map. So how can we actually access elements in a map? Let's say we have two elements in this map. This one over here, we have two elements. So how can we access this element? So we can access elements using keys. If you want to access a value of an element, you can use its key to get its value. So you can see log my map get, and let's get the second item using its key. The key is 1. So let's log this to the console, and we have key for second value. And then we can go over here and see we want to access the first one, which the key is name, and then we get the value to be KodeCamp. Okay, so let's talk about duplicate keys, or let's say duplicate keys in maps. So maps only allow unique keys. If you try to add a key value pair with a key that already exists we already have this value here. The second item, which the key is 1, and the value is key for second value. So if you try to add map set 1, and then we see, oops, like that, key for third value. It's third, not third value. And then if we log this to the console, okay, let's try to log our map entirely to the console and see what we got. My map. And let's log this to the console. So as you can see, the one we added last overrides the first one here. We have two keys, 1, 1. So the last one here overrides the first one we added. So we have key for third value, and then we have name KodeCamp. So map only stores unique keys. And we can also perform chaining on a map. We can actually say map, my map dot get name dot get 1. Now if you log this to the console, okay, there's an error here. So what this error entails is map get name, get 1. Okay, so notes here, please. We can actually see my map gets, want to perform the chaining. Okay, we've called the map. Okay, we can perform it directly here. Name gets one, like this. Or you can see set, since we have an empty map, let's just take this and then perform this chaining here. Then take this one as well and add it to it. Let's say like this. Okay, so now let's do away with this one and then log our map on the console. Okay, so we're still getting an error. Okay, let's do away with this one and log our map on the console. Okay, and this time around we have two items in our map. We have the first one with the key name and the second with the value. The first one, key name value KodeCamp. Second with key one and value key for second value. No, value key for second value, yes. So this is how we can perform chaining on a map. We can also check for existence and remove elements in a map. Okay, so checking for existence, you can use the has keyword. You can say my map. You can check if my map has, if it has a name. And check if it has name. Okay, this will, we have true. This is true because this map actually has the key of name and the value is KodeCamp. Okay, let's change this to a kind of num. So there's no num in our map, and then we get false. It will return false. So let's log this and we have false. So you can actually change this to 1. And in checking for existence, you use the keys to check if a value is actually in the map. So you cannot use a value to check. Let's say we have the value KodeCamp. You can use this value to check if it exists in the map. This will return false because there's no key. We only use keys to check for existence. So this is how we check for existence in maps. And then removing elements. You can also remove elements from a map. After adding element, accessing element, and checking for existence, you can also delete elements. Removing elements simply means deleting elements in the map. You can do something like, let's assume we have, we want to delete the second value. You can say my map deletes. The second value has a key of 1, so we can use the key to actually delete the value. Now we can log our map on the console. And we have only one item in our map. And because we deleted the second one, we only have the first one. Okay, so this is simply how we can delete an item in a map using its key. So we can also iterate over keys, values, and entries in a map, and we can clear the map. So let's see how we can iterate over keys, values, and entries. Okay, so we can do something like, in traditional objects, you can do something like object keys, object entries, and object values. So in a map, let's remove this so we can still have two elements or two items in a map. So we can see, let's iterate over this map and then log each key on the console. We can say for const key of my map keys. Let's log key on the console. So now if you try to run this, we have name and 1 because we have two keys. We have name and 1 as keys. So you can actually iterate over values as well. You can say values, and you can change this to value. Change this one here as value, because value of my map values. I want to log the values to the console, not the keys any longer, just the values. And then we have KodeCamp and key for second value. So it's in some ways it behaves like traditional objects in JavaScript, but in some ways it's just a map and not a traditional object. Okay, so in iterating over entries in a traditional object, you can see object entries. About this one, it's a map entries, and then you can grab the key and value. So this time around, we want to see, let's do something like I want to log key. Okay, let's say we want to log key and value like this. Because key value of object entries, because the entries will have the key and the value, we want to just log the key and the value as well. So if you run this, you have name, KodeCamp, and one key for second value, because we have the first key is name and the value is KodeCamp. Okay, let's give a space in between. I run this once more. We have name, KodeCamp, and the second one, the key is one, and the value is key for second object. So we can change this key here to an object, and then run this once more. As you can see, we have the key here is object, because we are using an object as key. Object, and key value. The value here is key for second value. And you can change this to anything. You can use anything as a key. You can even use a new map like so as a key and run this. And you can see object map is the key and the value is key for second value. So you can use maps as keys, you can use object as key, you can use anything as a key since it's a map, but not in traditional objects. So this is simply how we can iterate over keys, values, and entries in a map. So clearing the map, how do we clear the map? Okay. We have two elements in our map. Let's say two items in our map. So we can go ahead and say my map dot clear. We want to clear all the elements in our map, and then we say log my map like so. And if we log this to the console, we have nothing in our map because we've cleared everything in our map. We don't have anything in our map because here we've cleared it, and here we're trying to access to view the elements in our map, and we have nothing inside. Okay, so we can actually get the size of our map as well. We can see log my map dot size like this. And we can come down here and say log, okay, let's just copy this and paste it down here and run this once more. And then we have 2, 0, and we have an empty map. Because before we cleared our map, we had 2 items in our map. It's logging 2 on the console. Okay, let me just expand this a bit. Okay, clear this and run it once more. Okay, so we have 2 here as the size of our map. Then we cleared our map, log the size on the console again, and we have 0 because we don't have any elements in our map. Okay, so now we've seen how we can clear our map. Okay, the size and emptiness. We've also seen how we can check the size of our map. But basically, how can we check if the map is empty? We can do something like if my map dot size is equal to 0. This has to check for emptiness, and this will return true because this will evaluate to a Boolean, which is true because my map, after clearing the map, we have no items inside, so the size is actually 0. Then we log this to the console, and then we have true because the size of the map. But if you compare, if you try to check the emptiness or the emptiness of our map, you see it will return false because we have two elements in our map. So we log this to the console, we have false, true, and then we have 0, because after this we cleared our map and then we checked for its emptiness, and it was actually empty. So we have 0. Okay, basically, these are the operations we can perform on a map to create, add, and access elements, check for its existence, remove its elements, iterate over keys, values, and entries of a map, and then we can clear the map and we can check for its size and emptiness. So any question about the map? So we can proceed to the WeakMap and see its differences, why and how the map is different from a WeakMap. If you have any questions, you can go ahead and then raise up your hands so we can try to iron things up. But in absence of any questions, let's proceed. So what actually is a weak map? If we have a map, why then do we have a weak map? Oh, I think a map should be better than a weak map because a weak map is actually weak. That is an advantage. So a weak map in JavaScript is similar to a regular map, but with some important differences. But what these differences are, is they're designed to actually optimize memory management and facilitate garbage collection. We already know what garbage collection is. So the weak map only holds weak references to its keys. So these weak references must be objects. So this means that if there are no other references to an object used as a key in a weak map, the object can be garbage collected, even if it is still present in the weak map. Now, you know the reason why only objects are used as keys in the weak map. And in one of our classes, we discussed about primitive types, and which you can get a variable by value and by reference. So objects are being assigned by reference and not values. But if you have a primitive like a number, let's say we have a 2. We demonstrated that, but let's take a look at if you have const is equal to 2. Now the value 2 is being assigned to this variable 2. But if you have const 1 equal to this object, now this stores the address of this object in memory. So anything you change in this object, let's say for instance we have a name of code, and you decide to change, let's say you have log 1.name, and then down here you decide to change 1.name is equal to camp. Now what you are targeting is not actually this value. You are targeting the address of this object in memory. So once you change this name here, you are referencing the address in memory. So the name here, this value to this name will be changed. Now if you try to log 1 name again, let's see what you've got. Okay, at first we had code, and then the final one here we have camp, because we're changing the name here and we're referencing the address of this object in memory. For this here, the value here is 2. Let's say we have, let's 2 is equal to 3. Log 2. Now this is not a kind of a actual example, because if you try to, I will give you let's just try to experiment with this. Create a block of code and then try to check the name outside, and inside the block of code, try to change this one.name, and outside that block, try to access the name. But this one, let's say we have a block of code here. If 1, then grab this, bring it in here, and then log 2. And outside, also log 2 like this. Okay, I already have it. Okay, remove this, log this to the console. We have, in here we have, if 1, 2 is equal to 3, outside here we have let 2. Okay, we change the value here and we still have the value below 3, 3. Now take this, bring it up. We have 2, 3. In here, let's say we have 2, no value assigned to it. Bring this down here. And then check this. 2 equal to 3, and then say 2 here is equal to 2. We have 3, 2. And then try to experiment this with this object. Change the name of the object in here. Let's say this is an empty object. So add the name of the object in here and I'm trying to change it outside, or you can initialize it here and try to change it and see what happens. The behavior would be different because you're actually referencing the address of the object in memory. But let's proceed. You can actually experiment with that and then get back to it. So that is the reason why objects are used as keys in WeakMap to enhance garbage collection and all of that. So the XTs, when I say XT, I mean characteristics of WeakMap, the key XTs of WeakMap. Always keep it in mind that the keys of a WeakMap must be objects. A map, a key can be of any data type, a number, and a string, or even a Boolean. But then in WeakMaps, a key must be an object. And in WeakMap, there is no enumeration method. WeakMap does not support a method to iterate over its keys, values, entries, making it less versatile for enumeration compared to map. And garbage collection in WeakMaps, if any object key is in a WeakMap is no longer referenced elsewhere in the code, it can be garbage collected, helping to manage memory usage efficiently. So how do we create a WeakMap now that we know the difference between a WeakMap and a map? And if you don't know what memory management is or garbage collection is, you can actually revisit our previous classes, which I discussed about garbage collection and or you can make a little research on garbage collection and memory management. So creating a WeakMap, it's almost the same as creating a map. You can go and you can say my WeakMap is equal to new WeakMap like this. And if you hover over this, okay, I want to show you something very quickly. We have, this is WeakMap, then we have an object as a key and any. Any here means a value can be anything, but the object here must, the key here must be an object. Okay, so you can go ahead and see my WeakMap set, and here you can see an empty object and then a value, then you can say value 1. And then let's try to do something like my weak objects set, let's say a string, and let's say value 2. Let's try to get, let's say log my weak objects get name. And then let's try to run this code to see what happens. Okay, so we're getting an error. So invalid value used as WeakMap key. As you can see, we're getting a type error, invalid value used as WeakMap key. Now you can do away with this. And you cannot just reference this here in order to get use this as the key. Now let's try to run this. index.js, we have undefined. So what we do is we say const my object is equal to an empty object. Then we bring it in here. So we can be able to use it as a key to get the value of the weak map. You can say my empty object, and in here, you can also reference it here, my object. And then this time around, you can be able to get the value of the weak map. And then you can see my obj2 is equal to also an empty object. And you can just copy this here, paste it, change it to 2, and change it to my value 2. Okay, my value 2. And then we can try to access the value, which key is the second object. And then we still have the second result, which is value 2. And you can also check for existence. You can say if it has, let's check if it has this. Yes, because it has object 2, but if we change this to object 3, we don't have this key. Okay, so my object 3 is not even defined. So we can say my object 3 is equal to an empty object, but we did not add it to as a key to our weak map. So in this case, if you try to access it, you have false because we don't have it as a key in our weak map. We did not set it. Okay, so the limitations of the weak map over the map is no enumerations and no size property. Okay, you can actually try to do something like my weak map dot size. You get an error. There's no size property on the weak map, undefined. Okay, so it does not actually have a size property because its entries can be garbage collected, making it difficult to track its size accurately. So that's the reason why it doesn't have a size property. And you cannot loop over its keys, values, entries. You cannot use the method like for each or for off loop. So that's the key differences between the weak map and the map. Okay, so any questions on map or weak map, or map and weak map combined? Any questions so far? Okay, so in absence of any question, let's move forward and look at sets and weak sets. But if in case you have any questions, you can actually go ahead and raise up your hand so we can try to address your questions. So let's move over to sets and weak sets. Okay, so we just finished looking at maps and weak maps, and I believe we have a proper understanding of a map and a weak map. So what is a set? So a set in JavaScript is an object that represents a collection of unique values. It's actually similar to an array in terms of storing elements, but with a key distinction. So sets only allow unique values, meaning each element can only exist once in the set. And don't try to compare this to a map. A map only allows unique keys. A later key will actually override an earlier key. But then in sets, it allows unique values only, meaning each element can only exist once in the set. And you can compare this set to a mathematical set where you have only unique values, you have intersection, union, difference, and all of that, but we'll look at that in a bit. So it's actually the same thing, but not really the same thing. Just let's proceed. So a set has unique values. So if you add two values in a set, two values that are the same in a set, only one of them will be available in that set. So if you try to add a duplicate value to a set, it will be a kind of ignored, and the set will contain multiple copies of that same element. And then value types. So sets can hold values of any data type, including primitives, that is the string, numbers, and booleans. and even complex objects like arrays or other sets. And unlike maps, order is not guaranteed in sets, but order is guaranteed in maps, but in sets, order is not guaranteed. And unlike arrays, the order in which elements are added to a set is not guaranteed to be reflected when iterating over the set. So the order may be different each time you iterate. What are the use cases for sets? Okay, sets can be used for removing duplicates, checking for membership, and then combining sets. So membership, you can eventually check if a specific value exists in a set using the hash method. And in some cases, in some algorithms, it's better to use sets than traditional arrays because of O of n. That is the algorithm time complexity. It's advisable to use sets than traditional arrays. So how do we create a set? It's an object, and we can use a new keyword to actually create a set. And we can do something like this. How we basically create. Let me clear the terminal first. And this is how we create a set. You can see my set is equal to new set, like this. So this is an empty set, but then you can add items to this set. You can see one, you can see code, you can see an empty object, and basically you can see even a floating number like 10.6 like this. And then if you log this set to the console, you have, if let's log my set to the console and try to run our script, we have one code, an empty object, and 10.6. In this object, you can see name is set. And then let's log it to the console once more. We have an object with a name property and value of set. Then we have a floating number of 10.6. We have code and we have one. So let's try to add one once more. And then log this to the console. And we have only one value because we have duplicates values of one. So we have only one value here. We don't have duplicates. So that is one of the usefulness of sets. Okay, so how do we add and delete elements in a set? Okay, so let's assume we have only code and one in our set. Then let's run it once more. We have code and one. Okay, so now we can go ahead and see my sets add an object of name camp, like so. And this time around, if we log this, we have 3 items, one code and an object with name property, camp, and value. Name property, then the property name, and then the value camp. Then we can also add a floating number. My set add 10.6 as we did earlier. And this time around, we have 4 items in our set. And let's try to add 10.6 once more. Add 10.6 because we're adding duplicate values, and this time around we have a unique value of 10.6. Okay, so that is basically how we can add elements in a set. So how do we delete elements in a set? Now we have this. We have 4 elements in our set. Let's log our set once more, and then try to remove elements in our set. So how do we remove elements in our set? So we remove elements by using the delete method. So we can actually use the delete method here. Let's say delete, and we specify the value we want to delete. Let's say we want to delete this object with name camp. Now let's log this to the console once more. Okay, so this is an object that we want to delete. Okay, we can't do that except we have an object here becomes the name of the object, and then we bring in the name, and then we try to delete that same object. Okay, because here we are referencing two different objects, but if we declare a variable and assign an object to it, that variable is pointing to that object address in memory. So we can actually reference it anywhere and try to delete it. Okay, so let's try to delete something else like 1. And then this time around, if we log this to the console, we only have 3 elements in our set. And then let's try to delete my set, delete 10.6. This time around, we should have 2 elements in our set, and we have code and this object only in our set. So that is basically how to delete elements in our set. Okay, so there are a few important points to note with sets. Since sets only allow unique elements, trying to add a duplicate value using add, we have no effect as we did here. We added 2 elements, but only one of them appears in our set. So if you try to delete a value that doesn't exist in a set using delete, the method will return false, but then it wouldn't cause any errors. Let's, for instance, try to delete this. It did not cause any errors, but if you log this, let's actually log this because it's a method and they return something. Let's log like this. Let's log it to the console and see what it returns. Log this, and then we have false. Okay, so now if you change it to 10.6 and then log it to the console, it returns true. So this is useful in cases where if you want to delete an item in an element in a set, and if it returns true, you do something. If it returns false, then okay, let's for instance say if something like this, then let's copy this, let's cut it from there, and then paste it in here, then do away with this. So this is a conditional statement that you say if this returns true, say log let's say true, or else if it returns false, we log false to the console. So this is where you make your decision. And let's log this to the console. We have true here on the console, and let's change this to 10, which evaluate to false, and then false it's returned. We have false. This is where you make decisions. It depends on what you want to do. The delete method is useful in that case. So this is basically how we can delete elements in a set. And method chaining. A set also has method chaining where you can add elements. You can say dot add 20, and then another dot add 40 like so. Then you log this to the console. Then we have 1, 2, 3, 4, 5 elements. And after that, we deleted 1, the first element, and here we have 4. Initially we had 6, deleted 1, then we have 4 elements. Okay, so we can also check for existence in a set, checking for existence, and we can also iterate over the values in a set. So how do we check for existence in a set? We can do that using has. You can say log my set as 1. This time around, we don't want to delete, we are just checking. We remove this and it returns true. But let's check if our set has 2, and it will return false because there's no 2 in our set. Our set does not contain the element 2. So this time around it returns false, but initially it returned true. So that is how we can check for existence. So using has, it explicitly expresses your intent to check for the element's presence. So making your code more readable and all of that. So performance, has also has an advantage, the performance advantage. So it's generally more performant than other approaches like trying to find the element using iteration, which has an O of n. O of n time complexity. But if you use has, it has just if you iterate all the elements, let's assume the element is at the end of the map, then you have O of n, because well, this is the time, because if you have 30 elements, it will take the algorithm 30 to iterate over those 30 elements to get to the last position and then find that element, if at all it is at the last position. That is, so n is the number of elements in your set. But if you are using has, it just has a constant time. Just say O of 1. This is constant state, linear, constant time. O of n here is linear. O of 1 is constant. You don't need to iterate over anything. Just get the value where it is. That's how it is done. Okay, let me not bore you with algorithm stuff. And you can also, there's another method that is not recommended for performance reasons. You could technically iterate over the set using a loop and check for the element, but it's not sufficient. As we mentioned, the time complexity is linear, while using has, it's a constant time. So how do we iterate? How do we iterate over values in a set? You know, a set only has values. It doesn't have keys. So we cannot iterate over the keys or entries. It only has values. So we can only iterate over the values of a set. So let's assume we have, oops, let's undo this and then bring back our set. Okay, so now we can iterate over for const item of my sets. Just log the item like so, and you run this. Here we have one code 20 and 40 because we have how many elements? We have 1, 2, and then we changed this. We added 20 and 40 as well. So we have 1, 2, 3, and 4. Okay. So this is how, and you can say my set that for each, and you can say elements. And this is you can say log elements. This is a higher order function for looping through. We want just to iterate over. If you go, we still have one code 20, and then this takes also an index. And here you can do something like, if you don't want to use the traditional loops, you can do something like the index, like this, a space, and then the elements like this. Okay, this is the element, this is the index. So, okay, this is not a traditional arrays, my bad. This is not traditional arrays, so you can't get, set doesn't have index. Offset, also known as offset, where you can access those, and it doesn't have that. So this will actually return the value. That is the reason why we're getting the value as the index here. The index is also the value when it comes to set. Okay, so you can use spread on set as well. In an array, you can say something like my array is equal to, you say that my set. Then if you log your array, let's log it to the console, and then we have a traditional array here. And this time around, we can go ahead and then do something like my array dot for each, and then we can say elements, and then the index of the elements. We can log something like the index and then the elements like this, because this is a traditional array. and then we come up with what we want, or we can say index plus 1 to make it more human readable. We can do something like this. We have 1 here is 1. The first item is 1. The first element is 1. Second is code. Third is 20. And fourth is 40. So if you want to get the index, you can just convert this to a traditional array and then go over it. So, but if you try to iterate over a set, it doesn't have offsets, so that will return indices. So you can choose, you can go with the for of traditional loop, or you can go with the for each higher order function that to loop over the elements of the set. So it all depends on you. So you can actually check for the size as well. Let's do away with this one, this, and this. You can say my set. You can actually check for the size. Then we will show 4 because we have 4 elements in our set. So that's checking for the size. The size property, which is the same as the map. The size property in the map. You can also access the size property on the set. So you can check for size and emptiness. So how do you check for size? Oh, sorry, emptiness. You can do something like equal to 0, and this will return false because we have elements in our set, so it is not empty. Okay, so that's basically how we can check for size and emptiness. But if at all this is empty, then this will return true because it is empty. Okay, so that is just how we can operate on a set and all of that. And a set has there are other operations on a set. Let's say in basic mathematics, you can operate on a set, but then JavaScript does not provide an inbuilt method for these set operations like union, intersection, and difference. But you can achieve these operations using methods like for each, or the spread syntax and new sets, or all those things. You can achieve these methods. But then you have to write all these algorithms by yourself. Let's say we want to check for union. Or you know what, the union of a set, what is actually a union of a set? So the union of two sets, A and B, contains all the elements that are either in A or in B. Okay, let's go back to mathematics. So if you don't understand, just if you taught basic mathematics, you understand what I'm talking about. The union of two sets, A and B, contains all the elements that are in either A or B, but not in both. So how do we achieve this with basic algorithm? So we can go over this this way. Let's assume we have this here. Let's explicitly define our set A. Say const set A is equal to new set. And then we have, let's say we have an array with 1, 2, 3, 4. Okay, 1, 2, 3, and 4. Then let's copy this, paste it down, and then change the name to set B. And here we have, let's just say we have 3, 4, 5, and 6. So what the union of these two sets will be 1, 2, 3, 4, 5, 6. Just 1, 2, 3, 4, 5, 6. It will get these elements. Coming here is you see that okay, there's 3 in A and there's 4 in A. So let's ignore it and then pick 5 and 6. So how do we do that? How we do that is we can say we can write a function that will do that for us. We can call this function union, and then we can pass in the parameters of set A and set B. And inside of this, we can say we can declare a new set here. And this is const new set is equal to new set like this. And what else do we want to do? We want to actually iterate over the values of set A and the values of set B and then add them to this set we've declared here. Always remember, set will always ignore duplicate values. So while activating and adding, this new set will now ignore duplicate values. So we can say return new set like this, but then it will return nothing. Then if you call this function here, call this union and then pass in set A and set B. And let's try to log it to the console. Log this to the console here. Okay, we have an empty set. So how do we go about this? We say we iterate over set A and add the values to this new set, iterate over set B and add the value. And while the values are being added, this new set will ignore duplicate values because 3 and 4 are duplicate values. So what we do is we say set A dot, we use the for each method, say dot for each. Oops. Okay, that's basically, okay, let's say dot for each. That is basically a template dot for the higher order function for each. So we say value. What we want to do is we want to simply add this. We say new set dot add value. So while iterating, it will start with 3. This will add the 3 to this new set. Getting to 4, this will add the 4 to this new set. Getting to 5 to be added to the new set, and 6 will be added to the new set. But since it's set A, it will start with 1, 2, 3, and it will be added to the new set. So when we get to, let's copy this, paste it here, and then change this name to set B. And now, when it's time for set B to add the values to this new set, the new set will encounter 3 and 4, and it will ignore it because they are duplicate values. Then it will add 5 and 6. Then we simply return our new set in this function. So we log this function. The function will return our new set, and we'll be able to see it on the console. So we have 1, 2, 3, 4, 5, 6. And that is union in basic mathematics. So this is actually sweet. And always remember that if you have any questions, you can go ahead and ask. So this is how to implement union. The set simply ignores duplicate values and all of them. You can actually, if you need 3, you can actually add another set C, or you can the spread operator here to accept any number of parameters, and then you can iterate over those parameters and then add each value to the new set and then return the new set. It depends on your functionality. Okay, so we've shown how we can implement union in JavaScript without any inbuilt function for that. So what about intersection? How do we go about implementing intersection? Okay, let's change our function into intersection like this. And then we also have a new set, but this time around, let's remove this. We simply remove our new set, or we simply remove those 2 for each functions, and then let's try to log this to the console. Okay, union, we're logging union, of which now we have intersection like this. And then if you log this, you have an empty set. So how do we implement our intersection function? So first of all, we need to understand what intersection is. So intersection of 2 sets A and B contains only the elements that are present in both A and B. So what are the elements in A and B? We have 3 and 4. So after implementing this function, what it will return a new set with 3 and 4. So how do we go about that? How do we implement this functionality? Okay, so first of all, we have to iterate over the first set. So this is just the logical reasoning. Let's look at it this way. We have to iterate over the first set. So if after iterating over the first set, on each value of this set, we will check if this set B has a value. So if this set B has the value, we will add it to this new set in our intersection function, because they intersect, this set A and set B intersect with 3 and 4. So we check, does set A, after iteration, when we get to, we'll start iteration, we'll start with 1, and then we check set B doesn't have 1. So we'll skip, we'll not add it to this new set. We'll skip to set, we'll skip to 2. We check set B doesn't have 2. So we will not add it to this new set. But we'll get to 3, set B has 3. So we add this 3 to this new set because set A and set B intersect with 3. Then we check for, they also intersect with set B with 3 and 4. So we simply add it to this new set. So how do we go about this? By just this simple explanation, you know how to go about it. We first of all iterate over set A using the for each loop. So this is a basic template. The array here is the set A, and then we can say this is the element. Okay, let's leave it as the element. The element in set A. So first of all, we check if set B passed here as a parameter. If it has, we use the has method. So as you can see, this is always, it is a catch name string, and this the has method is actually a catch because it's a function. That's why it's called a method in an object. So it's a function. It's always catched. So it's a promise. Here it's showing you that it's a promise that returns a boolean. But in here, what we know is we're not working with promises. We're just returning. It returns a boolean. So if set B has a value in set A, it will return true. And then what is in this block of code will be executed. But if it returns false, what is in this block of code here will not be executed. So let's say if let's change it to value actually. Let's say value, and then if set B has a value in set A, what we want to do is we want to add this value to this our new set. So we use the add new set dot add value. So this is as simple as it is. So we'll first of all check if the set B has a value in set A. If it has, then we'll add this to this new set. This new set is the intersection of set A and B. If the intersects at is 3 and 4. So let's log this to the console and see what we got. So here we have only 3 and 4 because set A and set B only intersect with 3 and 4. So that is just how we can implement intersection using basic algorithms. So the difference of two sets contains elements that are in A but not in B. So we have, here is the first set and the second set. So the elements in this set but not in this set is the difference. So what is the difference here? 1 and 2. So how do we go about implementing the difference? Okay, first let's change this name here to difference and change this one here to difference as well, and then log it to the console. And then we have an empty set. Please do not try to confuse yourself. The difference of set A and B is 1 and 2. They did not say the elements in the second set that are not in the first set. They said the elements in the first set that are not in the second set. So the elements in the first set that are not in the second set are 1 and 2 because 3 and 4 are in the second set. Okay, so let's go ahead and try to do this. So how do we implement this? Is a bit trickier. So we can say, we first of all change this to, we pass in the set A into this set B. We say set A. Now this new set contains all the elements in set A. So log this function here. We have 1, 2, 3, and 4. And the reason why we're spreading it is because if you spread it here, this is a traditional array. And see how we are representing this traditional array in this set. So this will become a traditional array in a set with just, this is just a regular set with the elements 1, 2, 3, and 4. but we don't want to duplicate. We're avoiding duplicates. So what else do we want to do? After spreading the set A in this new set, we want to iterate over set B. So if we iterate over set B, we want to delete the values that are in set A are in set. In fact, we want to only return the values that are in set A and not in set B. So any value that is in set A and set B, we will delete it, we will remove it. We want to actually return values that are in set A and not in set B. So we will iterate over set B. So any value that is in set B and also in set A, we will delete it and then return only values that are in set A and not in set B. That is the difference of set A and B. Then we say set B, we'll iterate over set B. We'll say for each value in set B, what do you want to do? We say new set, delete value. Then we return the new set. You understand? We are not concerned with 5 and 6 because 5 and 6, we don't have anything to do with it because it is not in set A. We only have 1, 2, 3, 4. And what we are concerned about is the values in set A. So what value in set A do we have in set B? It's only 3 and 4. So if set B, each value in set B that is also in set A, we will actually delete the value and return the new set. Now, if we log this to the console, we have 1 and 2. So while iterating over set B, we encounter 1 and 2, but these values are not in set B. And then we move over to 3 and 4. We are not just an algorithms. This is just basic set operations. So let's not take it. Okay, so any questions on sets? You are always allowed to raise up your hand so we can go over it in absence of sets. So let's understand what weak sets are. So it was introduced in ES6 that it differs from a regular source. So the key, so in a weak set, keys can only be objects, non-registered symbols, unlike regular sets, numbers of it and all of that. So weak set has this object used as keys, as we earlier saw in WeakMap. Weak set is their weak reference behavior. As a key, is in a weak set is no longer referenced by any other strong to that object itself. The garbage collector object and all of it. So for private data and objects and all of that. But there are other important considerations in weak, since weak sets don't hold strong reference to their key of a weak set. And then why the keys in a weak set can be garbage collected is you store in the weak set are also properly cleaned up when they are no longer. So that's basically the difference between, just say once my weak set is equal to new, that's as simple as creating a regular. So any any questions on sets? Any questions on set or with set? Okay, so if no questions, we can proceed. Next item on list, which is BigInt. Okay, so most of us don't know that this is tricky, because when I started, I don't even understand. I never understood what they were meant for, and I came to understand that we have several JavaScript. It will get to too large, and precisions with big integers coming. So this actually was introduced in ECMAScript 20, and it's actually a data type specific for the standard number type. So they reliably represent integers around 2 to the power 53 minus 1. Calculation by yourself. 1. So big integers, large integers without losing precision. The key statistics of big integer, they can handle integers much larger than the number type. Data can lose precision. So unlike the number data type, which can lose precision for very large or very small decimal values, BigInt maintains exact precision for its entire range. And then the literal representation, you can also represent big integers by appending the number with letter N, and we'll see to that in a minute. So in creating big integers, you can actually do something like, let's say let number equal to 23n. This is no longer a number, but it's a big integer. Now, if you hover over this, what you see is BigInt. And then let's say let number 2 equal to 23. Now let's hover over this here, we see number. And let's hover over this one, now we have BigInt. Let's say log type of number, and then copy this one, paste it down here, and change this one to 2. And then log this as well. Let's clear our terminal so we can see it very well. Log this as well. We have BigInt and we have number, because the first one is a BigInt and the second one is a number. And if you don't want to make it a literal, you can say BigInt, and then you can pass in 23. And this is the same thing. If you log it to the console, we have BigInt and number. So this is basically how we can create big integers, 23n and 23. If you don't want to use the BigInt object, so what can we use big integers for? Because some of us may actually be saying, this is useless. It doesn't have any use. We can't even use it because regular numbers are actually okay. But what about when it comes to financial calculations? BigInt is valuable for financial applications that require precise calculation with large numbers, such as representing very high value transaction or complex interest calculations. Python has this, Python can represent complex numbers. most of us don't know that a number can take a form like, let's say, number equal to 2i plus 3g. This is a complex number. This number comprises of the real parts and the imaginary parts. And let me not take you to advanced mathematics. We have the imaginary parts and the real parts. So I here, let's remove this. And let's see, this I here is the imaginary part, and 2 is the real part. And then I is equal to the square root of, let me say, do something like square root of minus 1. So the square root of minus 1 is I. So I to power 2 is equal to minus 1. But let's not go into advanced mathematics. Python has this, it represents complex numbers. But in JavaScript, we don't have that. But like big integers are kind of, they don't really represent complex numbers, but they represent big numbers. Okay, so creating big integers. We've already learned how to create big integers, but then we can also see, we can create hexadecimal. We have hexadecimal numbers, right? We can make it a hexadecimal big integer. We can do something like this is, let's say, f, then n. If you hover over this, it's a big int, but it's a hexadecimal, literal, big int literal, with which we append it with. And if you remove this and then hover over this now, we have a number. Okay, but if you append it with n, we have a big integer. So what about, we have octal literal. This is a hexadecimal literal. This x here makes it hexadecimal. Then if you want to create octal literal, then you change this here to, oh, this is actually an octal literal. Then we remove, since it's not hexadecimal, octal is from 0 to 7, because they are base 8 numbers. So we don't want to reach F represent hexadecimal ABC from 0 to 9 ABC, because they are base 16 numbers. So we can say 7777 here, and this is octal. You know, it is yes. Now if you change this to 8, you get an error, because this O here represent octal digit expectation. It's an error because the octal digit expectation, and because they are base 8 numbers and they stop at 7. So now you no longer get an error. So this is an octal literal, big integer octal literal. So you can create octal literals with big integers or all of that. And if you log this to the console, we still have the type of, first one is a big integer and the second one is a number. So how can we use big integers? We've already seen how we can use big integers. Let's say we have a number here. Then we can change this here. Then we can say number, let's number is equal to number 2n. So big int, and then we pass in number 2 like this, and then we change this here to 2, or let's leave it like this, and then we log it to the console. We still have big int, the first number 2 is the first one, but we're logging it last. So the last one here is a number. The first one here, this is a number, here is a big integer. So the type here is big int, and the type here for the second one is a number. So big integers are actually good for, let's say we have, let me just try to do something like this. Okay, so now if you hover over this now, number literals with absolute values equal to 250 or greater are too large to be represented accurately as integers. We are getting not actually an error, but a kind of warning. So if you hover over these 3 dots at the first of this number, so you get this. And let's try to log, let me just log number 2 on the console. Okay, now you are seeing this 2.333 exponential 29. So what this means is, if you want to get to this value, you remove this decimal point. You say this divide by 2 point, this divide by 10. Then every time you move this decimal point, you add 0 to the denominator. You move this decimal point on the numerator, you add 0 to the denominator till you get to this value. Because this is exponential 29. This means 2.333 to this 8 times 10 to power 29. This is what this exponential means here. But that is basically not okay. So this is just big integers and how we can use them. Okay, without using literals, we've learned how to use BigInt without using literals. But if you change this here to n now, look at these 3 dots, they're no longer there. Now, if you hover over this, you have this warning. But if you change this, if you append it with n, now it's no longer there. But then if you log it to the console, now we have this complete number with this n appended to it because it's a big integer and the type changes to BigInt. Now we no longer have exponential 26 or whatsoever that was there. But if you remove this now and then log it to the console, we have this 2.33 exponential 29, that BigInt number and all of that. Okay, so that is basically what big integers are and what they entails. So choosing the right method. So the BigInt literal is generally the preferred approach due to its readability and explicit indication of a big integer value. But then the BigInt function with an integer literal without n is without an integer literal n is discouraged as it might lead to precision loss. So, and the BigInt function with a string argument can be useful for passing BigInt values from string representations. Okay, let's assume you have this here as a number and you want to actually change this number to a big integer. This is just a number, you want to change it to a big integer. Now you cannot just say, you cannot do something like it's equal to number 2m. You get an error here. You get an error. Did you mean number 2? Cannot find, what you say, cannot find name number 2m. Did you mean number 2? Because you are just adding n to this variable here, which is not declared, and you get an error. To combat this, you simply use BigInt. You pass in the number to use the BigInt function to convert the number to a big integer. Okay, so basically we've also learned how to convert numbers to big integers to numbers. So we have implicit conversion and explicit conversion. So you can use arithmetic operators to add numbers and big integers. So let's experiment with something. Let's say we have const n is equal to 23. And then you see const n2 is equal to, let's say, 25n plus n log n2. So can someone tell me what the result will be here? Since we're adding a big integer to a number, what will be the result? Okay, it seems we don't know what the result will be. So let's log the value and see what the result will be. Oops. Okay, plus n. Okay, let's make this. Oh, it doesn't know this. Let's make this a 23 like this, a 23 like this. Oops. Can we make BigInt and other types use explicit conversions? Okay. Okay, so why am I getting this? Okay, maybe this is in strict mode. Using big okay. Let's see n2 string is equal to n2 dot to 2 like this, And then let's log n2 string to the console and see what we got. Do away with this first. Okay, an error, n2 is not defined. Oops, why did I do away with this? Okay, like this. Okay, so we have 25 as a string. Now we can do something like n2 string plus 23. Let's see what we've got here. Okay, 25, 23, and this is basically not recommended. So we have implicit conversion and explicit conversion. So how do we convert BigInt to other data types? So in converting it to string, this is basically how we can convert a big integer to a string. Converting numbers to big integers, we can easily use the BigInt function to convert numbers to big integers. Then converting big integers, so now we can convert BigInt to a number using number. We have a number function as well. We have, let's say we have number is equal to 23. Now, if you want to convert this to big integer, you can say const big integer of this number is equal to big int of n. Now, if you hover over this, you have big int. If you hover over this, you have a number. And then you can say const big number of number is equal to number big integer of number. If you hover over this, you have number. Now, if you log n, bn, and nn, let's check on the console and see what we've got. So we have 23, 23n, and 23. So after converting this number to big integer, we convert it back to a number and then we log it to a console. So you can actually convert a big integer to a string. You can say const big integer string is equal to bn to string like this. And then we log it here, bn s comma like this, log it to the console. And you can see numbers are highlighted here using yellow. And here, this is a string with a gray color, should I say white. So this is how we can convert number to a big integer to a number, and then big integer to a string. And then we can also convert number string is equal to n dot to string. This is the method here. And then we can actually add it here, ns with a comma, and then log it to the console. We have 23 string. In converting numbers and big integers, they are all strings now. So we have 23, 23. So that is basically how we can convert numbers to big int to other ones, and all of that. So what are the limitations of big integers? Why big integers can handle large why should I say big int? Okay, if I say big integers can handle big integers. Okay, why big int can handle large integers in JavaScript? It also comes with a kind of some kind of limitations. So we have precision loss during conversion. If you want to convert a big integer to a number, the precision will be lost. Then potential performance overhead. You know, JavaScript, the big int operations might have slower performance compared to number operations. This is because big int require more memory and potentially more complex calculations for some operations. But then, for most practical applications, the performance difference is small, so it can be neglected. And limited library support, since it was introduced late in years 2020, not all libraries support big integer. And then no bitwise operations. It is not designed for bitwise operations. You know what these bitwise operations are? These is a bitwise operator, this, and I think yes, these three things here are bitwise operators. But then we can't go into that because we don't even have time to go into bitwise operators. That is basic JavaScript. You were supposed to learn that when you were learning the basics of JavaScript. Okay, so a no math object method. These are basic things to note. No math object. You cannot do something like you can see math, this math floor, math, then you can see 23, 25. So this will simply return, okay, let's see, log. Now, if you log this to the console, we have 25 because 25 is the bigger number in this between these two numbers. So what is happening here? Okay, if you don't know what's happening on the mathematics, let me hint you. Let's assume we have the math object here, and then we have a static max here that takes in a b. You say if a is greater than b, return a. Else, return b. Something like this. Then you can see log max. Then you pass in 23, 25. Okay, then we run this. We have the same results. So all these are handled behind the scene for you, so you don't have to go ahead. And this actually is a class. It's a static method and the math object. Then you can also change if you pass in a string here. Let's say 23, you get an error. Okay, 20. Okay, this will convert this to a number. It will convert 23 to a number. Let's say we have a string here. We have not a number. Then you can go ahead and you can say if type of A is not number, you can say return now. But then let's add something so that we know this one is different from that one. Then we can come down here and then say here we want to make it we want to make it like this, and then do it again. Then we have none. First one is none, second one is none. Okay, so this is how these things are basically implemented. So even though they're abstracted, and abstraction is very, very important, but at least you have to know what's going on under the hood. So the maths, you cannot use this, this not why, I just wanted to hint you on how all these are implemented under the hood. This, you cannot do this with BigInt, let's say 23n here and 25, okay, let's say 25n, and then try to, what you're using, cannot convert a BigInt value to a number, maths, okay? So that is basically how, and in our function here, as you can see, we have only 2, but we can add another value of 39 and then change this to 4. And then run this once more. We have 39 undefined. Yes, 39. Where is the undefined? 39, 23. Okay, remove this like this. Then 39, 25. So here you just have to see the numbers. You use a spread operator to accept any number of arguments. Okay, but that's, I just want to hit you on how all these are implemented. Okay, so that is the limitations of BigInt. You cannot use BigInt with math object methods. You cannot use BigInt with bitwise operators, or you cannot use bitwise operations on BigInt. And then the library support limited support, also potential performance overhead, and precision loss during conversion. So you have to be careful while using big integers. So what do we have next? What we have next is, okay, as you can see, we have just 9 minutes to go. And I want to show you something. We have optional chaining. You can use optional chaining in function calls, array items, and you can combine it with knowledge coalescing. There is knowledge coalescing operator. And what I want to do is I want to jump optional chaining, and then I want to come to knowledge coalescing operator. And in here we cover optional chaining and knowledge coalescing operator. So it was introduced in ECMAScript 2020, the same time they introduced BigInt. So the knowledge coalescing operator is a logical operator that provides a concise and safe way to handle null and undefined values in your JavaScript code. So it allows you to define a default value that will be used if the expression on the left-hand side evaluates to null or undefined. Okay, so before we proceed, I just want to show you something. Let's say we have const age equal to 0, right? And what we want to do here is we want to say log age or 22. Now let's log this to the console. What do we have here? We have 22. Is 0 not a value? It's actually a value. Now let's change this OR operator here to a coalescing operator. And log this. We have 0. So I don't need to explain the difference now. I just wanted to show you this, so you, before I even explain the difference between the OR and this coalescing operator, you already know what the difference are. So if you change this now to this, and then you do this, you still have your empty string. But if you change this to an OR operator here, what you have is 22. This will evaluate to false. So this OR checks, it considers 0, undefined, false, empty strings as they are just null and null. But what coalescing operator checks is the null, it's only null and undefined. So basically, before you have something like const name is equal to KodeCamp, and then you say something like const result, okay, result is equal to name, return name, else you see let's change this to n. We're saying this is deprecated. Declare was marked deprecated here, was because a name is a kind of a keyword in JavaScript, so it's deprecated. So let's come here, do this, oops, like this, and then like this, and then here we see camp, and then we see log results, like this. So this was actually the traditional way of doing this, and you see we have a ternary operator here. We can do away with this, and then we can see our coalescing operator, right? And then we go, and then we have KodeCamp. And then let's remove this to null. And then we have camp, because this is null, this is false, and this will evaluate our KodeCamp. Our camp here will be returned. Then let's change this to an empty string, and then use OR. We have camp, and then let's change this to coalescing operator, like this. We have our empty string. So this, how we can use this with calling functions and doing other things as well. And there's one important thing I want to show you about the coalescing operator. So you can see greet. Here we have name is equal to guest, and in here you can see log let's say hello name. Now if you call this function, let's say greet, without any arguments, you have your guest. So what this is doing under the hood is checking, is there any remove this here. Then in here, you can see name, or here you can see name, guest. So this is what is happening under the hood. Hello guest. Then if you pass in your name of code, then you run this function once more, you have hello code like this. So this is basically what's happening in this function, the default parameter. So that is basically how the default parameter operates under the hood. So that is what is happening. It explicitly handles that for you, so you don't have to go doing all of that. So let's show you how you can use this with the optional chaining. Say const user is equal to, and in here we have name KodeCamp, and then we have profile, an empty profile. Then we can, if you try to say log user profile name, user profile name, let's log it to the console. We have undefined. But then in here, you can say user. Okay, let's remove this profile and then run it once more. We get an error. Bam, this is what I want to show you. So the optional chaining comes in. Let's use an optional chaining here. So if profile is undefined, it will simply stop execution here, right here, and return undefined instead of throwing an error. So let's run this once more. Oops, oops, oops. Okay, so we have here name. Okay, so we have undefined. So this time around, we don't have error, but we have undefined. So in this case, we say, okay, let's change this to name. And then you say, if there's no name, just say KodeCamp like this. Then we'll go ahead, we'll have KodeCamp. And then remove this optional chainer, and then remove this one as well. In fact, remove this line, leave it like this, then run this code. We have KodeCamp, user.name, okay. So this is an object with not inner name property. Okay, let's say user n like this. KodeCamp. Okay, we can use let's say we have greet. This is our name KodeCamp, and we have the method greet. So greet is simply a function that logs. Okay, it simply logs hello. Hello. This dot name. This is an arrow function. Let's change it to a regular function in order not to get errors. Function like this. Okay. Now we can use optional chaining. You can say user. Does it have a greet method? So you can do something like this as well. You can, if this greet is a function, then you call it. If not, it will return undefined. Then you do something like this. Hello KodeCamp. Okay, remove this console log here, so that we don't get undefined. We have hello KodeCamp. And now it is, I just want to show you how it can be used with function calls. So let's remove this here and then change this to greet. This is not a function. Then do it once more. We're getting an error saying user.greet is not a function. We say KodeCamp. Oops. Okay, user greet is not a function. Okay, we're actually calling it here. We're actually calling it. Let's not invoke it. So user.greet.name, or we can say user.greet or KodeCamp, like this. Okay, we're not logging it. You can say log this user.greet or KodeCamp. Okay, so we have greet. So let's remove this greet entirely and then do this once more. So we have KodeCamp. We don't have this property on the, so we can do this with arrays. Array is equal to, let me see, an object with a name property of code and age of 4. So we can see log array at index 0, because we have this object at index 0 with optional chaining. What is at index 0? The object. So the age, like this. And then log it. We remove this one here. And remove this one as well. We have 4. So try to remove this age property and then run it once more. We have undefined, but try to remove this optional chain and this operator here and run it. We still have undefined because this is an object. It will not throw an error. Okay, let me try something because I really want to get those errors. I really want to get that error. No, okay. So here, let's say we have let's say we have 1 and 2. And then remove this page. We want to log the first index. Okay, now let's make this the second index. We got 0, index 1, index 0, index 1. So there's nothing in the second index. Do it to have undefined. Then remove this optional chain operator, run it. We still have undefined because okay, there's nothing in the. Then we can combine it to the collecting operator here, and then we say it should return 3 if there's nothing there. And then we have 3 instead of undefined. So we can use this to prevent errors. So if there's nothing, instead of throwing errors, don't throw errors, or you can see no value at index 3, like this. No value at index 3. Okay, so before we leave, let's say we have a function takes a, let's say this is n. I take a parameter of n. I say return n or null. So here it's a return statement n or null. So if you call this function, let's say const result is equal to, you call this n, you pass in 2, and you see if r log superb, like this. Then let's try this. We have superb. Then remove these 2 here. No arguments. And then call this again. There's no superb. Say else log no superb. So this is how these things can be used in code bases or programs or anything. This is how you can use the collecting operator. You can see, you can change this to, if there's n, return n or return null. Okay, you can say m, okay, return n here or return null. Now, if you pass 2, it will still behave the way you want. And if you remove this argument here, there's no n, it will log no superb. But that collecting operator makes it simple, no, like this. Okay, so, and precedence. Precedence, I think I've included it in the docs. You can go ahead and try to read it and understand how. So in today's class, we looked at optional chaining, collecting operator, the BigInt, map, set, WeakMap, weak sets, and we've seen how applicable they can be in JavaScript. So thank you all for paying attention, and thank you for attending the class. So any questions so far?